Okay, geometry. There's no ifs, ands, or buts about it. This is going to be one of those lessons that there's a lot of stuff to write down. So unfortunately, it's just a lot of lists of things, and so there's a lot of writing and writing and writing. You take a lot of the quadrilaterals. Those are all the four-sided figures. You get down to the special quadrilaterals, and basically, if they tell you it's a parallelogram like this, then these are the 5 basic properties. And so it's a good thing in the givens of a proof, let's say, or an algebra problem. If they tell me it's a parallelogram in the directions, I got all these things to sort of play with. I got all these things that I could use. Opposite sides are parallel to each other, so it would look like this. Opposite sides are congruent. AB is congruent to DC. BC is congruent to AD. Opposite angles congruent. So all of angle D would be congruent to all of angle B, opposite angles. And then this angle would be congruent to this angle. All right, it starts to get a little messy when you put all the marks in there. The diagonals bisect each other means they cut each other in half. That doesn't mean the diagonals are congruent. So you wouldn't say DB is congruent to AC. You would say this little segment is congruent to this little segment. This segment, I'll put a V shape on it, is congruent to this segment. So this would be like a midpoint in the middle. So like AM is congruent to MC. DM is congruent to MB. That's what they mean by the diagonals bisect each other. And then any two angles in a row, they call them consecutive, like angle D and angle C. They're going to be supplements, C and B. They're going to be supplementary. B and A, they're going to be supplementary. A and D, they're going to be supplementary. So how can we use these things? If it's algebra type problems or if it's a proof problem, I'll do it as an example in a proof of how to write these things down. So you could say something like, if they tell you it's a parallelogram in the givens, they tell you it's a parallelogram, then you could say something like, as a statement, you can say, well, AD is congruent to BC, and as a reason, this is what we need to really practice, is opposite sides of parallelogram are congruent. Don't even need to make it an if-then sense. Just say opposite sides of a parallelogram are congruent to each other. So please understand each shape that I'm going through is going to have a little bit of a list like this that you're going to have to write stuff down. There's going to be some pausing on your end in order to pause it, write it all down, and then just kind of listen to the rest of the explanation. That's going to kind of slow it down. But I needed to write them out in advance so that I can fit it on the video. Otherwise, it would take too long. The next thing. The next shape that we're going to cover is rectangles. So in rectangles, I think you guys know what a rectangle looks like. It is a parallelogram. So this list looks short, but actually it's all 5 of these properties plus all 4 angles. I'm going to use a different color. All 4 angles are right angles. So angle D is a right angle, angle G, angle E, angle F. So it has all these properties. Notice consecutive angles, supplementary, still works because they're all 90. But they're all going to be right angles if it's a rectangle. The other thing that changes is that up here, DB was not congruent to AC. All right, diagonals were not congruent. They cut each other in half. That's still true. They cut each other in half, but now they were congruent to begin with. So all 4 of those little segments are congruent. How do we do this in like a proof? I can say something like DF is congruent to GE. All right, it has 7 properties. It has these 5 plus these 2. If I say DF is congruent to GE, then my reason would be diagonals of a, and you got to say what shape it is, of a rectangle are congruent. The diagonals of a rectangle are congruent to each other. Moving on. All right, now rhombus. Rhombus is that so-called diamond shape. All right, rhombus is the so-called diamond shape. So it has all 5 properties of a parallelogram, the one at the top, not necessarily a rectangle. All 5 properties of a parallelogram, plus all four sides are congruent. Not true in the other two. All four sides are congruent. The diagonals are perpendicular bisectors. So the diagonals still cut each other in half, like the other two. But now they are perpendicular where they meet. Not true here. Not true in the one up above. They are now perpendicular bisectors of each other. So they cut each other in half, and they meet and make four right angles in the middle. They also bisect the angles they come in and out of. Man, I don't know if I want to write all this. So opposite angles are congruent, like all of G is congruent to all of R. But then they also bisect each other. So like this is congruent to this. It's bisected. And this is congruent to this. All four of those are congruent because G was congruent to R and then cut in half, cut in half. It'd be like division property. And you can do the same thing up here. O is cut in half. S is cut in half. S is bisected. So rhombus has a lot of helpful properties here. So it has all the properties of a parallelogram, all five of those. But in addition, all four sides congruent. That's probably the one we use the most. But the second one we probably use the most after that is that it makes right angles in the middle and that you get right triangles out of that. And we're going to do a lot with right triangles within a rhombus shape. Find the perimeter, go around the outside, stuff like that. So that is going to be something big when it comes to a rhombus. Give me another second or two. We're going to take it off the page and move on to the next one. So these are all parallelograms, by the way. So we started with a basic parallelogram, then a rectangle, then a rhombus. And basically the next shape is if you combine them all. What kind of shape is a parallelogram, and it's a rectangle, and it's a rhombus? Think about it. What kind of shape is a parallelogram and a rectangle and a rhombus all at the same time? Well, let me move this out of the way. Well, that would be your square. A square has all five properties of a parallelogram. It has all the properties of a rectangle. It has all the properties of a rhombus. If you put the congruent tick marks on it, you'd go nuts. All four sides congruent. Diagonals are congruent, so all the way across, and they bisect each other, making four little congruent segments. The diagonals meet and form right angles in the middle. They make right angles in the corners. Look at it, it's starting to get a little crazy in there. Opposite sides, again, are parallel. All right, and those 90-degree angles, because it's also part rhombus, those 90-degree angles are actually cut in half. That's not true in a rectangle. I want you to notice that. In a rectangle, this diagonal doesn't cut it into 45 and 45. It doesn't split the 90 in half. But in a square, because it's part rectangle, it makes it 90. Rhombus bisects. That does make it 45 and 45. It splits them right in half in each corner. All right, you can't even read my writing. There's so much stuff in it. But 45 degrees on either side. So every right angle has been split right down the middle. Split right down the middle. I should backtrack. I didn't use a proof one in this one. So let's say there was a proof in this. You could say something like, oh geez, what would I use in this one? I would say that's unique to a rhombus only. Maybe the right angle's in the middle. I could say something like angle GKO is a right angle. Or I could say the lines are perpendicular in the middle. And you would put as a reason diagonals of rhombus form right angles. So I could have said right angles, or I could have said they're perpendicular, something like that. Now for a square, what can I do that's kind of unique to a square? I mean, you could take any one of those statements that we used before. So I can do something as simple as, W C is congruent to CR. Although I can do that even for a parallelogram, but I could say diagonals of a square. They have to tell me it's a square in the beginning, though. Diagonals of a square bisect each other. All right, so like this one was cut in half, and this one was cut in half. They bisect each other. All right, but I just sort of trying to give you guys an idea of what it's like to, if you had to use this in a proof. We're not going to make you memorize all this stuff. We'll let you look at a list like this in order to either set up an algebra problem or help you fill out a proof. You'll have this list of stuff that you could use. You just got to get used to looking at the list and using the list. For kites, they have what's known as two disjointed pairs of consecutive sides congruent. So it has consecutive sides congruent, but it's not like a rhombus where you can just pick any two and go all the way around, or a square. Pick any two going all the way around and they're all congruent. This has one pair, in this case on the left, and a disjointed pair, totally separate. I have another pair of congruent segments. So that's what they mean by the two disjoint pairs of consecutive sides congruent. The diagonals are perpendicular in a kite. So they do make four right angles there in the middle. Notice the diagonals are not congruent though. You got a long diagonal, K to T, and a short diagonal, I to E. The long diagonal will bisect the short diagonal. So the short diagonal is cut in half, but not the long one. The long diagonal will bisect the angles it comes in and out of. So like this is cut in half, and this is different, and it's cut in half. All right, so the long diagonal bisects the other diagonal, and it bisects the angles K and T were cut in half. Not true at E, not true at I. Let's see. And one pair of opposite angles are congruent. So if you have a kite shape, the angles at the end of the shorter diagonal, here's my long diagonal, this angle and this angle. So up here would be angle I and angle E would be congruent to each other. One pair of opposite angles are congruent to each other. Again, it's a big long list of stuff that we got to sort of force our way through here. So we would say something like, let's say KI congruent to KE. One pair of consecutive sides of kite are congruent. That's kind of an awkward one. We probably won't use that in a proof. I'm kind of not real happy that I picked that one. Isosceles trapezoids. So isosceles trapezoids, there's your properties here. I'm going to have to pause this in about 30 seconds because the video will run out between 14 and 15 minutes. But isosceles trapezoids, the legs are congruent to each other. Those are the non-parallel sides, and the bases are these two parallel parts. All right, the bases are the parallel sides. I'm going to pause it right here, and I'll pick it up in video number 2.